Assalamualaikum and selamat pagi, salam sejahtera. So, wish you all in the good condition, stay at home. So, today we try to continue our chapter for the subject MEC 435 Computer Aided Design. So, we look at chapter 3, the design process and the role of CAD. Okay. So as we know, in design process, any product begin with a need based on customers and markets demand before being translated into a finished product. So first of all, what is a market demand? So market demand describes the demand for a given product and who wants to purchase it. So this is determined by how willing consumers are to spend a certain price on a particular good or service. As market demand increases, so does price. When the demand decreases, price will also go down as well. Same goes now during COVID-19, petrol price decrease because of people now don't use it because everybody need to stay at home. So market demand is the total of what everyone within a specified industry desires and can help guide missions when building and e-commerce sites. So knowing market demands can help inform future online businesses what industry is most profitable to enter into. Therefore, many business owners will have to conduct market demand research. So, in its pure sense, manufacturer is producing an item for in the form a detailed list of requirement, including toolings, machines, assembly, okay, and some that a human or non-human robot could do it. Okay, so they produce toolings, machine assembly in manufacturing, and they produce it with either human or non-human robots. Okay, it depends based on different company, different methods. Okay, so the design engineers uh, plays a vital we call that very important task. So the design engineer produces drawings and specification, the manufacturing engineer, the tooling and fixtures, the shop supervisors, the actual machines and production lines. So as we can see in the world now, in the world-class engineering, world-class manufacturing, large manufacturers such as Toyota, Nikon, and all Japanese company, let me say, follow this step. And small shop commonly take a set of drawings and specification and do everything except the design portion of the job. So a shop may make suggestion that will improve the design and or manufacture, but the decision to accept or reject the suggestion has to be with the designer. Okay, so suggestions come from the designer who wants to make a production. The accept or rejection suggestion has to come from the designer. So when someone requests a shop to make it work, someone has now ceded design authorities and responsibility to the shop, and the shop could compensate accordingly. So there are a lot of type of design, or we call that engineering design. So as we can see here, uh, there is maybe five types of engineering design. So as follow the types: original design, adaptive design, and then we go for the redesign, selection design, and industrial design. The most difficult design in the uh, every types of manufacturing, the most harder to design is original design, where the new concept, parts, or product never existed before. So in the engine original design is also called innovative design. So this form a design is at the top of the hierarchy. Okay, so original design most the harder design to employ in the industries. So it employ an original innovative concept to achieve a need. Okay, and sometimes but rarely the need itself may be original. A truly original design involve invention, of course. So they need invention process during the original design. So the design of the microprocessor was one such original design. So we can see the design of microprocessor, for example, was one such original design. And then we go easier compared with original design is adaptive design. Okay. This form design occurs when the design team adapts a known solution to satisfy different needs to produce a novel application. Uh, for example, adapting the inject printing concept to spray binder to hold particles in place in a rapid prototype machine. This is a adaptive design. The in and also we can see the 3D printing also come with the inkjet printing concept actually. So the next types of design is we call that redesign. Okay, or we call that industrial design. Okay, industrial in the industrial design. And in okay, we see that the redesign first, redesign first. So in the redesign, the most easier, the easier type of design. So this is much more frequently engineering design is employed to improve an existing design. So the task may be to redesign a component in a product that is failing in service, or to redesign a component so as to reduce its cost to manufacture. So often redesign is accomplished without any changes in the working principle or concept of the original design. So when redesign is achieved by changing some of the design parameters, it is often called variant design. So the next is selection design. Most design employ standard components such as bearing, small motors, or pumps that are supplied by vendors specializing in their manufacture and sale. Therefore, in this case, the design task consists of selecting the components with the needed performance, quality, and of course, the cost from the catalogs of potential vendors. And then lastly is industrial design, which is deal with improving or improvise the appeal of the product to the human sense, especially its visual appeal, or we call that for the aesthetic only. Okay, and more artistic than engineering, but still an important aspect of kind of design compared with other types of designs. And it was a design consideration on how the human user can best interface with a product. So this figure shows that the closed loop product cycle. Okay, so the aim of this closed loop PLM, we call that product life manufacture, is to close information gaps between different phases and process of the product life cycle of individual products. So we can see this loop can be backward, for example, provide using data to design processes, or forward, for example, providing production and assembly information to recycling processes. So as we can see in this uh, figure, so after shipping and marketing, okay, so there is also can into the uh, goes back into the uh, design process. Okay, and this figure shows the product cycle in conventional manufacturing environment. This is commonly processed, which is I can briefly explain the conventional process of the product cycle in the conventional manufacturing environment. We can see that the product goes through two main process from the idea conceptualization to the finished product. So two main process, the design process and manufacturing process, to come together to finish the product. So this is a design, okay, and uh, the other one is in the production, okay, in the production. So it is a two main process here, design and production, to make the product. Okay. On the other hand, this is example of product cycle in computerized manufacturing environment. So the operation of manufacturing plant through either direct or indirect computer interface. Okay. So with engineering environment and identify existing and future related tools, a study of the typical product cycle is necessary. So what is a design actually from your understanding? So design is an innovative and highly iterative process. So it is also, we can say, the process of decision making, and the process of identifying the deeply understanding a problem or need, thinking creatively, and then identify the best solution, uh, and using project management and teamwork skill to drive the entire process. And the design is implement the solution, and then the designer also implement the solution, test it, and modify what they have designed. And engineering design integrates mathematics, of course, basic sciences, engineering sciences, economic, and other subject for the creation of component, system, product, and process. Okay, so that's why the importance of design. There is also a morphology of design. So morphology means what? Morphology means a study of form or structure. So morphology of design refers to the time-based sequencing of design operations, So it is a methodology of design by which ideas about things are converted into physical object. The logical order of different activities of phases in a design project is called the morphology of design. So a design project goes through a number of time phases. Morphology of design refers to the collection of these time phases. And as we can see here, we can have 7 phases of a design process. For the phase one, conceptual design, embodiment design, and then we have a detailed design. So these three design we call that primary design phase. Primary design phase. This is this three primary design phase. I will explain later on. And the other four of morphology design: planning for manufacture, planning for distribution, planning for use, planning for retirement of product. We call that this one is phase related to production and consumption cycle. Okay. So in conceptual design, this stage also called feasibility study. A design process always begin with feasibility study. The purpose and activities during feasibility study are to ascertain there really exists a need. For example, the existence of need must be supported by necessary evidence rather than the outcome of one fancy. Okay, so in conceptual design, you need to search for a number of possible solution, and then we have to evaluate the solution. Okay, so for example, in the conceptual design, you just make a concept from the existing product. We can see in producing the vehicles, there are concept car, okay, before they produce in the this is a concept car. This is a conceptual design before they produce the real car. And then we look at the embodiment design. Okay, this is the stage art which the concept generated in the feasibility study is carefully developed. Okay, and in embodiment design, the model will be tested. Okay, so study the advantages and disadvantages of different solution is the task in the embodiment design, and they need to check for performance, quality, strength, aesthetic, and etc. in embodiment design. Okay, so it is a feasibility study in the embodiment design, the important activities. Okay, and then we can see the detailed design. So its purpose is to furnish the complete engineering description of the tested product. So the arrangement, form, dimension, tolerance, and surface properties of all individual parts are determined in the detailed design. So also the material to be used and the manufacturing process to be uh, adopted, and etc. are decided in detailed design. So finally, complete prototype is being tested. So the fourth one is planning for manufacture. This phase includes all the production planning and controls activities necessary for the manufacture of a product. So the main tasks at this phase are preparation of process sheet, specify the condition of raw material, specify tools and machine requirement, and also include for the QC system, production control, and planning of the flow system. And then planning, the fifth is planning for distribution. So in this stage, the economic success of the design depends to the skill exercise in marketing. So this phase aims at planning an effective distribution system. So different activities of this phase, for example, design the packing of the product, planning effective and economic warehousing system, and then planning advertisement techniques and so on. And then the sixth phase is planning for use or consumption. The purpose of this phase is to incorporate in the design all necessary user-oriented features. So the step in planning for use or planning for consumption is design for maintenance, design for reliability, design for convenience in use, design for aesthetic features, and design for prolonged life, and lastly, design for product improvement on the basis of service data. And lastly is phase 7, planning for retirement of product. So this is the phase that take into account when the product has reached the end of useful life. So a product may retire. We call is this product may retire when it does not function properly, or another competitive design emerges, or changes of taste or fashion. Okay, like we, as we can see nowadays, they don't need a CD. Okay, we don't need the CD anymore. They use a USB and so on. Okay, so this product we call is uh, not competitive compared with other product. So the need to consider the following aspect: design for several levels of use so that when service life at higher level of use is terminated, okay, the product will be adaptable for further use with less demanding level. Okay, and designing the product so that reusable material and long life component can be recovered. So modularity in design can be contemplated instead of integrated design. And design to reduce the rate of obsolescence by taking into account the anticipated effect of technical development, and examine service terminated products to obtain useful information. So the detail of the first three phases we can see here. The phase 1 is conceptual design. Okay, first we define the problem. Okay, by problem statement, benchmarking, QFD, and project planning, and then we gather the information either from internet, patterns, and so on. And then concept generation, we do the brainstorming, creativity method, and so on. And then evaluate and select concept, yeah, from the decision making. Uh, from the selection criteria, we use the Pius chart, and then decision matrix, and so on. I will explain later. And then the embodiment design, for example, after the conceptual design, we goes to embodiment design, product architecture, okay, arrangement of physical element modularity, and then configuration design, and then parametric design. We do the embodiment design. Okay, in this embodiment design, we try to arrange physical elements, selection of material or manufacturing, what is the suitable material, what is the suitable manufacturing process. And of course, during the manufacturing process, you need to do the robust design, which is when during the, for example, injection molding process. Okay, you have to know what is suitable temperature, what is suitable pressure for the product come out. So this is a robust temperature, robust uh, pressure you selected to make sure the product produce with no defects. And lastly, in the first three phases, is phase 3 detail design. You make a detail of your product, okay, by for example using PDS, right? uh, uh, PDS concept, or what we call product design specification. So in the PDS, you have to document it, all the contents, all the facts related to the outcome. Okay, so you have to read the details of the PDS, product design specification. You need to do the product design specification in your mini project also. So it is important to work with consumer, for the customer, and analyze the marketplace to produce. So uh, you need to do the list of requirement necessary to produce successfully product. So in your mini project, you have to do the some PDS, what we call the PDS. So the designer should constantly refer back to this document to ensure designs are appropriate. So now we look at the principle of DFMA, design for manufacture and analysis. So what is principle DFMA? So as we can see here, how the principle of DMA. So there are 11 or 12 principal guidelines in design for manufacturing and assembly, the FMA. So the first one, to minimize number of components, so assembly costs are reduced, okay, by you minimize number the components. So assembly costs, of course, are reduced. So the final product is more reliable because there are fewer connection. So this assembly for maintenance and field service are easier to implement. Okay, you assemble and disassemble. Maintenance is easier, and reduce part count usually means automation is easier to implement. So work in process is reduced, of course, by minimized number of component. Work in process is reduced, and there are fewer inventory control problems. So fewer parts need to be purchased, which reduces ordering costs. Okay, so this is very important to minimize the total number of the part. You can cut the cost. Okay, you can cut the cost of assembly, and also you can have fewer parts, which is fewer costs, and which is you can reduce ordering costs. So minimum, you can minimize the part, minimize cost and everything. And the second one is use modular design. Okay, use the modular design. So design time and effort are reduced by using the modular design. Okay. In the terms of use modular design, each sub-assembly in modular design, we have each sub-assembly should consist of 5 to 15 parts, let's say. So maintenance and repair are facilitated. Automated and manual assembly are implemented more readily. And of course, by the modular design, we can uh, inventory requirement are reduced, and final assembly time is minimized when you use the modular design. So modular design mean one product, there is no assembly, only consists uh, maximum 15 parts, let's say. We can have a sub assembly, but only consists of 5 to 15 parts maximum. Okay, so by this using modular design, you can uh, maintenance and repair works are uh, facilitated. Okay, lebih mudah lagi lah kalau you gunakan modular design only one product. So dia punya sub assembly maximum is 15 parts. Okay, and the third one is minimize part variation. Okay, minimize part variation. So minimize part variation by use of flexible components. So flexible is mean that to minimize use of the flexible component, because flexible components such as rubber, belts, gasket, cables, and so on. So these flexible components are generally more difficult to handle and assembly. By use multifunction design, you use standard commercially available components and or use common parts across product lines. So there is opportunity to apply group technology by implementation of manufacturing cells may be possible when you use multifunction design. And design part for multi-use, so you have to design part for the multi-usage. Okay, design the simplify the fabrication. Okay, so the part features, for example, chamfer, taper should be designed on mating parts. And use of fastener. Okay, so this is non-essential parts. You use a fastener, spacer, washer, o-rings, connectors, leads, and so on. Can make easier when using when you using the assembly or assembly process. And then minimize assembly direction. Try to minimize the direction of assembly. For example, using a snap feed. Is more rather than threaded fastener such as nuts and bolts. Sometimes you use snap feeds is more convenience. So in terms of direction, and then maximize the compliance. So you try to maximizing the compliance. Okay, which is fit or not, and then about the tolerance and so on. Okay, and then minimizing handling. Okay, try to eliminate or reduce the handling parts. For I said before, rubber, gasket, and so on, cables. So this is difficult to handle or assembly, and eliminates or simplify the adjustment. So this required in the assembly process. So adjustment are time consuming in assembly. When you make adjustment, it is time consuming, and designing adjustment into the product means more opportunities for out of adjustment condition to arise. Yeah. When you make more adjustment, this is more opportunities for out of adjustment condition. Sometimes you adjust, sometimes you come back to problem again. And avoid flexible components. As I said before, you have to avoid rubber and so on. Flexible components make difficult and using when you design for assembly. Okay, and we go for the design for manufacture. Okay, DFM, design for ease of manufacture of the collection of parts or products. It is more as a philosophy. Okay, it is the way thinking that can be applied to the component or product. So there are aspects to look into DFM. For example, operating parameters, how the operating and non-operating environmental simulation, okay, test requirement, and so on. So there are in DFM there are three key elements. For the first one is process selection. Process selection, you have to analyze the material and process method for the individual component based on tolerance requirement, production volume, and so on. And then for the process material, you have to uh, have a description, uh, uh, what is the advantages of this material and so on. Motivation by using the material which is cost, and then for example free machining, uh, you use the free machining grades, and many polymer grades are turned to a process. Okay, tune to the process, and then try by the process selection. uh, you have to know uh, how to avoid the secondary operation by minimize the need of secondary operation. So example of pre-painted steel, no, there is uh, no need the secondary process. Okay, and then for the reducing the number of process stages, so eliminate unnecessary process stages through components minimization, elimination of finishing process, and combining the process. Okay, and then design of the process. You have to know the design process. For example, in machining, casting, injection molding, you have to design, you have to know the benefit and limitation of the process. Okay, so this is what I explained before. Process selection knows the tolerance, and then reducing the process, you have to minimize the component. And then the third one is design of the process. You have to know when you make what process, you have to know that you have to design the process itself, the parameter itself. Okay, the line, and how you want to use the process, you have to know. So this is a design of the process. You have to make sure when you manufacture the design of these three element, you have to know. Then design for assembly uh, is also important in the DFMA. So design for assembly, you have to simplicity, which is minimize part number, and then standardize on the material usage, and use the widest possible tolerance. So when you make a tight tolerance, it's more difficult to assembly. And then minimize non-value added operation. Okay. Second operation, third operation may take cost and time. And choose material that suit function and production process. Of course, you have to choose material. And then of course, when you make assembly process, you need the teamwork. And try to reduce number of part I have explained before, and ensure that the remaining parts are easy to assemble. For the small component, when the last remain parts, so make sure is easier, or the last part easier to assemble the product. So what is the outcome when you can design for assembly? So you can shorten product design time. Of course, the time's very important in the process. Okay, so you can reduce assembly time, and you can simplify assembly process, and then of course you can reduce total material cost, and improve quality and reduce defects when you design for assembly, and reduce labor content. And other design consideration, of course, product use, design life, and human factor consideration. For the product use, okay, the principle is consumer is always right. Right? So you can read this slide, why this consumer is always right. Okay. Uh, for example, when customer expectation are compared with the various product design characteristic to identify those that are not addressed, and to develop and optimize product plan in cooperation, design modification accommodating the dominant expectation. Okay, so users of product are increasingly aware of their opportunities to sue manufacturers. So you have to consider uh, the product use, and then the design life. Okay, you have to consider the lifespan of the product. So this is a design life. So you need to know when the product uh, retired, product retired. So design life, you have to know the cycle or hours of operation. And the third one is human factor consideration. So in this section, all designers should consider the operator of devices, component, or system under development, and strive to produce user-friendly product. So you have to consider also human needs, human factors. Okay, so you have to know the person that use the product can maintain and repair the product. Okay, simply to repair the product. Okay, so now we try to look at design application. There are three major computer application in engineering environment: design. We have a computer, for example, computer aided design, and then analysis, computer aided analysis, and manufacturing, computer aided manufacture. So first of all, we look at computer application in design. So conceptual and also geometric modeling design stages use a lot of computer application. So in both hardware and software. Okay, so widely used the CAD tooling. Right? So computer application design, we use a CAD So for the hardware, it is a 3D scanner, digitizer, pointing devices, and so on. And the software, for example, software of AutoCAD, CATIA, Pro-E, SolidWorks, and so on. And then we have computer analysis, using analysis to optimize the design stages. I have explained this before in chapter 1. So it is involved the FEA, CFD, and so on. So for example, using Abacus, ANSYS, and other software. And computer application in manufacturing. So you apply also computers in manufacturing. This I also explained before. You use CAM tools, computer aided manufacturing, to complement with CNC machine and software. Okay, so it is involve wide areas from process planning to marketing. So the next one is digital mockup. Okay, so digital mockup or DMU is concept that allows the description of product usually in 3D. So also in CATIA you have you can click the digital mockup. So comprised of 3D model which are positioned in 3D space to represent the form of the product to be developed. So you can see in the digital mockup. So the objective is to have important knowledge of the future or the supported product to replace any physical prototype with visual ones using 3D computer graphic techniques. So the roles of digital mockup is to allow full visualization of complete product in 3 dimension, and permits collaborative engineering as all users can see other users' work as it evolves, and improper errors detecting by locating clashes interference earlier in process. So when using the digital mockup, you can see the product, either it clash or not when using the assembly process. You can use the digital mockup. So DMU goals: reduce time to market, reduce product development costs, and increase product quality by allowing a greater number of design. Okay. And then we have we continue with the CATP, okay, computer aided process planning. This process planning begins with an examination of the engineering parts drawing and ends with manufacturing process plan and instruction, which is acts of preparing processes documentation for manufacturing of a piece, part, or assembly. So there are 2 levels of process planning: high level planning, which is general planning, identify, grouping, order, instruction, and low level planning, detailed in general plan above. Okay, I will explain later on. And the process planners follow a consistent set of steps to develop process plans, which is involve primarily stock preparation, plan generation, and specification of manufacturing parameters. So CATP, or computer aided process planning, is the use of computer technology, can say, to aid uh, or to help in the process planning of the part or product, so in manufacturing process. So CATP is the link between CAD and CAM, in that is provide for the planning of the process to be used in producing the design part. So in this CATP, there is a linkage between CAD and CAM module. So it provides for the planning of the process to be used in producing the design part. Okay. So CAPP is the use of computer technology to aid in the process planning of a product or parts in manufacturing. So process planning is production organization activity that transform a product design into a setup of instruction, which is sequence, machine tool setup, and etc., to manufacture machine part economically and competitively. So as we can see in this slide, so CAT-P is fully integrated for the CAD and CAM. Okay, so traditional manufacturing process planning, okay, different way with different companies. In some companies, the machinists are merely given the drawing and asked to complete the job. In some cases, the manufacturing engineering gives a detailed list of the step of the machining operation and also mentioning the work center on which the operation has to be carried out. So it is the duty of the manufacturing engineer within the company to write the process plan for the new part design to be manufactured in the machine shop. So the process planning task is usually too much dependent on the experience and the judgment of the engineer working in the production shop since years. Okay. So until recently, the whole process planning tasks were being done manually. However, the individual engineers have their own opinion about what constitutes the best routing for the manufacturing of a job. So due to this, there are differences in sequence of machining operation developed by different planners. But now the computers are being used to manufacturing planning tasks. The use of computers for process planning enables removing a number of problems associated with the manual process planning. And of course, benefit from CAPP or CAPP, we can reduce process planning effort, which is take a time for the plan. And of course, it can save direct labors, materials, scrap tooling, and of course the time. And uh, of course, when we use the CAPP, so greater process will consistent. So in the variant approach, computers, you have to understand that variant approach, computers search for existing or similar process plans of similar parts families using codes, retrievers, and then edit according to new process sequence. So using a variant approach, there is commonly implement with they call the GT code. So code to select a generic process plan from the existing master process plans, which is baseline process plan develops for each part families and edits to suit the requirement of the parts. So this is called retrieval types, retrieval types process planning system or CAPP systems. So in the retrieval type of CAPP system, the various parts to be manufactured are classified and then given codes and grouped within certain families. So we have to classify given codes and group within certain families. So within each part family, standard process plan is established, which is stored in the computer. So when established is stored in the computer, and the process plan is also used for the new parts that come under the same families. So this system developed in such that it's easier to retrieve the process plan for the new work parts. So the whole process plan documents the operation as well as the sequence of operation on different machines. So the retrieval CAT-P system offers lots of flexibility as one can do lots of editing and changes as per requirement. All right. While generative approach, in the generative process, a process plan is created from scratch for each component without human involvement. So in the generative process planning system, the new plan is made automatically from scratch for each part using the computers without involving human assistance. So the computer program uses a set of algorithm that enables to take a number of technical and logical decisions to attain the optimum final manufacturing process plan. So one has to give certain inputs to the system like detailed description of the part to be manufactured. So this APP system synthesizes the design of the optimum process sequence based on the analysis of the parts geometry, material and other relevant. So this is a figure for the variant approach of the CAPP from the cap of from the design and then we can transfer to the GT code. Okay, uh, and then from GT, using the GT code you can goes to the process plan, which is you can edit and do some process for the next process. So meanwhile, in the generative approach, you have part descriptive in the system and the process being faci- facilitate information for the manufacturing. For example, here, okay, with the combine for these two system, they process plan become start with the another post processing. So in the variant approach, we can see this is use GT code or code to select generic process plan from the existing master process plan. So this is a baseline process plan developed for each part families and edits to suit the requirement of the parts. So about 90% of the baseline process plan is ready. So planners only retrieve and add another 10% by modifying the baseline plans. So commonly implemented with the GT code, this is a GT code and parts are segmented into groups based on similarity and each group has a master plan. So challenge is in developing initial GT code classification and coding structure for the new part. So another process plan, different GT code, and the process plan is different GT code. So a new process plan must be developed manually and entered into the system database to create a new baseline process plan. So the in, uh, impractical in situation where small batches of widely varying parts are produced. So it is not suitable for when it is small batches and when you small production. So these advantages of the variant approach is quality of the process plan still depends on the knowledge and background of the process planners and have have possibilities of repeating mistakes from earlier plans that were stored in the database. And the good advantages is a good investment where the hardware and software required for the CAPP system is not too high and offer shorter development time and lower manpower to produce the process plan. So it is a straightforward process since it make use for existing process plan that are already proven in the form of catalog from which the required process plan need to be selected and edited. Okay, so I have explained this one before. We need a GT code in the variant process. And for the generative approach, a process plan is created from scratch of each component without human involvement. Some said without human involvement, some said half human and non-human. And these systems are designed automatically synthesize process information to develop process plan for a part. So does require or store predefined master plan. So there is no master plan, but only required predefined master plans. So contain the logic to use manufacturing database and suitable part description schemes to generate process plan for the particular parts. So most of the contemporary CAPP system being developed applies generative approach. So most of them use generative approach. So generative approach eliminates disadvantages of variant approach and bridges the gap between the CAD and CAM. So implementing generative CAD-P system required for more effort. Okay, so the advantage of the generative approach, fully automatic and up-to-date process, and there is disadvantages for the generative approach is required a major revision of decision logic. For example, if a new equipment or processing capabilities come in. So CAPP implementation techniques whereby there is uh, we call decision use logical decision, which is a traditional approach. So it is a simplest approach to code the process capabilities in a computer program. So there is three methods: decision table, decision tree, and combination what we call AI. Okay, uh, artificial intelligence. So in the decision tables, okay, it is you draw a table and partition into condition. So the program structuring tool which provide readable documentation as an automatic byproduct. Okay, you make a table and then you make decision yes or no. And then decision tree, a graph with single roots. Okay, single root and branches emanating from the roots. So it is easier to customize, update, maintain, visualize, and develop compared to decision table. And sometimes when you use decision tables, at the ends of the branch, you draw the action. Okay. So the tree as computer code is converted into flow charts. So the starting nodes is the root, and every branch represent a decision statement which is either false or true. Okay. So this is decision tables. Okay, decision tree, like I explained before. So this is decision tables. Okay, you make two condition and then you make a yes or no. Okay, so the action is A, B, C, D. So you uh, like I said, the decision table use a branch. The action is a last. Okay, so you convert the table into the tree. So another approach for the uh, uh, what implementation techniques in the CAP-P, okay, is expert system techniques. Use artificial intelligence, which is the most popular of expert system in CAP-P due to qualitative, subjective, imprecise, and company-specific nature of the process planning knowledge. So designed to cope with such as knowledge characteristics, okay, much easier to modify and customize than the fixed logic conventional systems because the knowledge in expert system is clearly represented and separated from the planning or presumption mechanism. Okay, so frequently used method to solve problem in an AI is the theorem proving techniques. So artificial intelligence techniques have often been found to be used in generative CAT-P system developed. Okay, this is figure shows the part drawing. We have essential element of retrieval or variant type KP system. So you have a part drawing or master plan here, and then you make a coding system, and then you use uh, decision table. So you can have a standard plan by what you are refer to the decision table. Okay, so another approach in CAT-P, other than variant and generative approach, is hybrid approach, which is used when a problem in generating a purely generative process plan occurs. So systems using this method must cooperate with process planners with high technical knowledge, and the planner's responsibility in interpretation of decision data and or working drawing. So it can be done through use variant approach to develop a general process plan, and then use generative method to modify it. Okay, we have a variant approach, and then use generative method to modify, and use generative approach to generate as much process plan as possible, and then use variant approach to fill in the details. So you first use generative approach to generate, and then secondly you use a variant approach to fill in the details. So select either to use generative mode for complicated part features or variant mode for fast process plan generation. Okay, so this is a figure for the example of CAT-P using resource internal representation, and then part design internal representation, and process plan representation using the CAT-P system. So another computer integrated system which important in manufacturing is computer integrated manufacturing. Okay, which is integrated of total manufacturing enterprise through use of integrated system and data communication coupled with new managerial philosophies that improve organizational and personal efficiencies. Okay, basically involve the integration of all the function of an enterprise. Okay, so this is the new manufacturing enterprise wheel, which is very famous wheel produced by Society of Manufacturing Engineers, SME. Okay, so 6 areas of manufacturing enterprise. Okay, which is the first one is success of enterprise depends on the customer. Okay, and then second one, dealing with organizational structure of the enterprise, and then share the knowledge, which is database and experience, and then system that are involved and used in the total enterprise, resources and responsibilities of the enterprise, and the sixth one is manufacturing infrastructure. So there is 6 approaches to in the SME. So this is CIM implementation in terms of function and hierarchical level of CIM. Okay, so you can read by your own self for this figure, and there is a lot of hierarchy in the design process using CIM. Okay, and last is benefits of CIM. It can improve operational control, and then improve short run responsiveness consisting of engineering changes, processing changes, machine downtime, and so on. And the third one is improve long run accommodation through quicker and easier assimilation of changing product volumes, new product additions and introductions, different parts mixes, and so on. And the fourth one is reduces inventory. Of course, you want to reduce inventory. You don't want to keep your product in the warehouse for the so long. And the lastly is increase machine utilization. So that's all for our topics in the chapter 3. Okay, what is the design process and the role of CAD? So I hope you can learn and study a little bit more. You can read this notes and search by your own self in the Google's, YouTube, and so on during your um, COVID-19 semester for this time. Okay, thank you.